Okay, so on Monday, I announced I'm going to make a video and make a deck of slides to go over the Homework 3 Part 2 demo step by step. But some of you might notice yesterday during the office, I have been, I'm sorry to say that, but I have been sick since Monday, late Monday, early Tuesday. So I basically, if I don't have meeting, I'm basically sleeping right now. You can see today I'm in bed right now. I mean, I went downtown to have a meeting that I have to go to around noontime, but the rest of the time. So I think I feel better now after kind of death sleeping for more than 12 hours. So I think I'm going to make a video tonight and then send it to you. I'm sorry about that. But I do want to spend some time to go over some of the instructional philosophy with all of you. I think it's important for you to sometime to learn the course, to understand a little bit more about why we're learning this subject and why we're learning this way, okay? And also, if we have more time, I will be happy to answer any question in Homework 3, Part 1 or Part 2 as well. And then you're waiting for my video to come up, okay? And also, I will provide another deck of slides, which you can look at the video and look at the slide at the same time. So, so I just want to say, maybe I'll ask all of you, what do you think the main difference between taking a course in physics or calculus versus taking a course in programming? What do you think is the similarity and difference between this two set of curriculum? Anybody?
Logic.
Go ahead, Janet.
Oh,
sorry. You can go first. Yeah.
No, you're good. You can go.
All right. Yeah. Just I think like I would say like in programming, like the most important thing is like you really like code and you spend some hard time figuring out like who links to who and who relates to who, and I mean that's really hard, but after all it's all about coding. It's all about like doing it yourself. But in I would say like calculus, there's still some like conceptual things that you can just playing with, but coding normally you can't. I would say that. Yes, that's
Okay.
what I want to say.
That's a good answer, Yui. Janet, you want to say something?
Also, like the similarity is logic. Like if you don't try to use that, obviously you're not gonna pass any of the classes. And then the difference, I think it's about the group work, because like mostly for programming, for computer science classes, if you don't work in a group, you're gonna get really hard time.
Okay. Okay. Thank you. Thank you for both of you. And somebody else want to say something?
I have one opinion or something I want to say is that, which is that for physics or for math, it is a self-taught class to some point or to some degree. Most of the stuff is taught by the professor. Like most of the concepts, you're gonna understand them during class. But when you're learning computer science or when you're coding, a lot of things you have to learn them by yourself. I would say the majority of things. When you're coding, most of the time you're going to be Googling things, which might not be the case for physics or math. So I think the degree to which the class is self-taught is higher for computer science. Then the similarity would be that in both classes you have to really commit and like sit down for a while and try to figure it out.
Okay, great. So I think all three appreciate. Thank you for all three comments. I think you're right. Your observation is right, and I'm going to tell you some of my observation, which is in a different track. I mean, I'm not saying what you're saying is untrue, but I'm actually have another observation. The key thing I'm trying to say here is that in calculus, the basic principle or you're solving a problem and those theory hasn't changed for about 200 years. I mean, calculus was driven by people who develop physics. They need to compute a surface or compute some kind of geographic property. And that mathematical theory hasn't been changed a lot. But programming is a field that has changed so dramatically. It's changed almost every month. So if you think about why is this particular programming language was developed, why is this particular library was developed, why is this data format was developed, is driven by the need of the industry. I have to be frank that IT is driven by about 90 miles from where we are right now. And in that process, you will have a lot of engineers in, say, a company like a Google. They try to solve a problem. Of course, they're using whatever tool that's available. And the thing is that then they realize after many of us are working on a similar problem, because we're going to encounter a similar problem. And I mean, just give you an example. If you want to calculate the geo distance, I mean, the code you're going to put is about maybe 20 or 30 lines of code. And 20 years ago, maybe is a 500 lines of code to do that calculation. It's just repeatedly people developing needs, and then people are getting better and better solutions. So from 500 lines of code to 20, and next year, it might be 1 line of code because it's being integrated into library. So programming, unlike calculus or mechanical engineering, I'm sorry that I know very little about engineering, mechanical engineering, but I'm just guessing that they have a tool. They basically not doing any kind of revolution or evolution of their tool very often. They're basically developed a tool that's actually used mathematics used for 200 years, still the same techniques you're doing. But in programming, what I realized the first time I write the first program is probably 40 years ago. I kind of see that, well, 40 years ago, we don't have all this nice tool that we have today. And it's very different. I mean, of course, the basic syntax, there still share some similarity. You still have for loop, you still have if then else. But the thing is that the usage of what language you're going to use or what tool you're going to use has been very different. It keeps changing. And therefore, I have been thinking about the instruction objectives for this course. I'm actually taking this as this is the second class of the CS curriculum. And I think the traditional computer science curriculum or programming curriculum, we're trying to emphasize on the linguistic perspective. But I'm actually thinking that it's very important. Somebody, can you mute your mic? Oh, thank you, appreciate that. For this course, I really think it's important that you use tool to capture the train about that evolution. What do I mean by that? In fact, I think to learn a particular language is, you can learn anytime, by the way. You can learn anytime you want, and you can actually take online courses to learn the linguistic perspective. But from time to time, I saw students using Google, using Stack Overflow, and then try to pick up the idea, and then try to grab that piece of code, shuffle into your code, and get it to work. So essentially, in a long term, as a programmer, it's very important for you to develop that capability to actually just grasp the most recent tool being developed and have the capability to integrate and then to try out. And through that process, you're learning not just about solving that problem, but you're learning about the train, about how the programming. And that is a very difference between programming or computer programming with many other subjects. And then this is somewhat different from all the subject you have to learn before you enter this class or enter the college in high school. That is pretty specific, is a curriculum driven. But here we're talk about the curriculum itself is try to give you some experience to develop that that paradigm that you know where to get the data from the newest one, because you need to do that because you cannot rely on your experience 5 years ago, because after 5 years from now, there will be better library, there will be better framework, and to solve exactly the same problem, much better. That's the result of everybody aggregate together. Okay, so the reason I mentioned this is that I think yesterday or the day before, there was one student from this class asked me a question, which alerted me to have this communication. He said, Professor Wu, does that mean we're doing plagiarism? I said, no. I mean, I don't know, one of you actually asked me the question about plagiarism. No, we're not worried about plagiarism for this particular set of homework, like homework 2 and homework 3, because we're focused on how you can reusing. There is something called reusability. In fact, gradually you will know that, I mean, by the way, ethics, plagiarism is something bad. Sorry, plagiarism is bad. Ethics is always very important for every programmer. And the thing is that on the other hand, you know that also reusability is very important because you want to always use the best tool. So therefore, I think that a lot of the code you will be seeing, you're not developing every single line for yourself, but you develop some in the process that you actually try to get hold of other things. For homework 3 is the same, for homework 2 is the same. And also for your final project, somebody asked me whether this everything is in C++. My requirement is just one component in C++. And you should be able to use any kind of tool that you want to develop, and that will be fine, okay? Because in solving a realistic problem, you need to know that you have to deal with a lot of real world situation. It's not just about a programming language. I try to emphasize here that that's my goal here is try to expose you to a real world scenario, to expose to distributed computing, to mobile application. By the way, yesterday I have the meeting after after the office hour. I had a meeting with the colleagues from Fujisu lab in Japan. We're collaborating some kind of application to do coronavirus detection. So they're actually accessing some of the code module that we developed under ecs36b, and then they actually show me through Zoom. They show me a demo. Using a smartphone application and using this to actually be detecting the sound of coughing, sneezing. I just told them that, oh, I'm actually sneezing. Maybe I can use the application to actually be able to see the environment sensor. And it's very nice. They actually integrate the piece of code that's doing signal processing and try to understand the sound, and using a little bit of machine learning library and using the smartphone and then all the feature. You can think about that. This is a realistic application. You're not developing all your code for signal processing, for AI module. In fact, I would say people talk about machine learning a lot. It's great for you to learn the detail about machine learning, but machine learning itself in the industry has been what we call commodity technology. Commodity technology means that it's nothing really new anyway. It's basically being packaged as a nice library or framework, and then you're just calling, pick up. Of course, you need to have some experience about which one you're going to pick. You're probably going to pick a few and try it out to see which one works the best. Okay, so I'm just telling you that this is something I feel the programming curriculum in 21st century will actually gradually move into this kind of style. because it's really the technology we're dealing with is just changing every day. And I really hope that UC Davis student, when you go out of our college, when you move into your career, either is a government or research or industry, that you have the capability, that you might not know everything, but you have the experience, be able to have the capability to solve real problem by finding the best tool and assemble them together and then solve that problem. And I try to mimic some of that within this class as well. So that's something I want to share with you. Any comment or response? I could be wrong, but I'd like to open up to talk.
I think you explained this very well, the difference between calculus and physics and computer science, because I think the reason why computer technology has become so much more better over the years, and you know, the technology is coming much more faster than you know, laws in physics and calculus, is because the way people use libraries and pre-made material, pre-made code. So without, you know, the C libraries or the C++ libraries that you have, you know, you wouldn't have all these technologies.
Right.
And so it's a good thing to encourage students to use other people's libraries, so we can optimize our own programs and innovate. Yeah.
Thank you. Any
Professor?
other? Yeah, go ahead, please.
I'm just curious, what's the name of application that you're working on with the team in Japan? Is that app named Cocoa?
Okay. I don't want this part to be recorded, but yeah, they haven't released yet. They haven't released public yet, and I think within the company they have to discuss. But the person who developed this program, she is coming to UC Davis next year.
Oh,
she is working with me. She's supposed to be here this July, but because of the coronavirus, she got delayed. And so that's why she cannot come here, but we still meet with her and her manager. And then we do that pretty much every other week. We develop that. And if you're interested, I can tell you more detail. But now Japan is still closed, and we're also somewhat closed. So we're looking at sometime in March that it will be, Japan will allow their people to come to US. Everything else has been taken care of. Funding and the visa has been taken care, and the agreement has been signed. It's just waiting for the coronavirus. So we're kind of in an interesting situation. Yeah.
Okay, so that is the application. Oh, the private company, not government company.
No, this is we're working with Fujisu. Fujisu is I think one of the biggest company in Japan. And this is their research lab, and we collaborate. And I have a relationship with Fujisu Lab for many years. They have been sponsoring my research. So we actually, under UC Davis, that we signed research agreement with them. Yeah.
Okay, thank you for sharing.
You're welcome. By the way, Saki, since you brought up this issue, I want to encourage all of you is that UC Davis is a great university. We have all kind of discipline, from biological science, school of medicine, animal science, agriculture, to anything, social science as well. We have a very good network of connecting to different parts of the company, different parts of the international relationship. I really hope that when you're staying here, try to utilize that. If you see any professors working on some interesting thing, you should actually try to get hold of them and try to see if you can get some experience as early as possible. And I just want to tell you one thing is that recently the social science communication, they're actually looking for people who can do programming, because you can see that they need to deal with data such as Facebook data or Twitter data. They definitely need people who can do programming and might not know a lot about social science, but they know a lot of social science. they don't have a lot of good experience or programmer to help them. So I hope that by taking this course, that you will be able to get opportunity both intra-campus or also in outside of the campus to get some kind of experience. Okay, I mean, programming, to be honest with you, experience is crucial. I mean, you really need to get involved in a project to practice those tools. I mean, think about that. A tool, if you don't use it, just like a calculus, you won't really master it. But even worse, I shouldn't say even worse or even more exciting, is computer science. The tools just keep changing. That's the difference between other discipline and the programming, because the tool itself evolves so fast. It's much faster than the, say, hardware or computer architecture. And therefore, it's very important for you to continue to get involved. Then you will be able to deal with the real problem and be able to grasp the newest tool that's actually available to solve that problem. And in that process, you can see the trend. You can see the trend about, okay, you think that 2 years ago, this tool, this year, this tool, you expect that will come up after that. And there is an innovation will come up through that experience as well, okay?
Thank you.
You're welcome. Any other have question before we close this one? So then I move to the group 5. I think today is group 5.
Yeah, Professor, I had a question about the PTD. We were supposed to talk about it last class, but we didn't get a chance.
Can you speak up a little bit? I can barely hear you.
I had a question about the PTD. We were talking about it. We were talking about it together last time, but I didn't get a chance to talk with you about it.
What's this? Barkava? Sorry, I didn't see. I heard PTT, but I didn't hear the rest. Bargava, are you still there?
1 second. I'm trying to fix my microphone.
Okay, sure, no problem.
Okay, can you hear me okay now?
Yeah, right now, perfectly clear. Yes.
Okay. I had a question about the petition to drop. I was supposed to talk to you about it at the end of last lecture, but I didn't get a chance.
Okay, all right. Which group you're in? Are you in group 5?
I think I'm in group 1.
Okay. Okay. Send me another email around 5:30. Would that be okay?
Okay.
All right. Sorry about that. Yeah.
Oh, it's fine. It's fine.
Yeah. You know what? Hold on there. I'm going to send you a private message right now in the chat. The rest of you can leave now. I'm just sending the. I tell you which group you should join. Okay.
Sure.
Yeah. Hold on 1 second. Yeah, my machine is spinning. Okay, why don't I stop recording first? Because